Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we are going to be digging into something that might, on its surface, sound very enterprisey, which is like resilience and retriability and all these things that make apps, you know, make sure they work no matter what the conditions are. But what I find really exciting about this is that it's the sort of thing that the thing that makes me always dislike an app is when it feels flaky, right? Like I don't want to have to try things twice. I don't want to have to refresh it to make sure that it worked. I just want it to feel solid. And so even for a side project, I think there are really good ways for us to introduce some of that kind of robustness. And one of the tools that we can use for that is called Temporal. So that's what we're going to talk about today, is an app called, or a service app. I don't know. You know what? I should probably bring up Alex and have him talk to us about it. So to teach us about it is going to be Alex Garnett, who you may recognize from Web Dev Challenge if you've been watching this year. Alex, how you doing?
I'm doing great, Jason. How are you?
I am. I'm very happy to have you here. Today's a little bit hectic. It's it's a lot of deadlines happening right now, so things are all over the place. I apologize everybody for starting a little bit late, but we're here. We're going. So Alex, for folks who aren't familiar with you and your work, can you give us a bit of a background on yourself?
Yeah, I'd love to. So I am a developer advocate at Temporal right now. Prior to that, I was a curriculum developer at Temporal. And prior to that, I wrote tutorials and documentation for DigitalOcean. So I love teaching. I love teaching complicated backend tools in particular, because I feel like that's the kind of thing where if you never learn it or you avoid it, like you wind up being like, how do I deploy my app? My deployment's broken. I hate deploying my app. And that's the
Right.
kind of thing that, in past lives, I spent most of my time on. So I like making that part of work easier for people.
Nice. And so, like, one of the things that I find really interesting about this approach, like, historically, when we start talking about the kinds of things that we're going to be talking about today, it starts to get extremely complicated extremely fast. So, one of the things that I'm thinking about is, let's say I want to make a database call, and based on the results of that database call, I want to update something in another service. Now, in order to do that, I have my app sending an HTTP request out to this database, which then needs to respond with some data. I have to take that data, send another HTTP request to the other service, and then that has to come back. And if I'm, somebody's trying to use this while they're in the car, they switch cell phone towers, and you just get that unlucky moment. You're on a train, the internet's super slow. You just, any number of things can go wrong, right? And that causes the first round trip to work, but the second round trip to fail. In order for me to try that again, historically, you'd start talking about things like queues, Kafka queues. You'd be looking at something like setting up Rabbit. What's it called? Rabbit MQ. You're
RabbitMQ, you
you're
got the Redis layer caching, you got
right.
your whole Airflow back. Yeah, like
And,
everything
and
is just queues on top of queues.
immediately, I have checked out. I'm like, you know what? That's for a company bigger than mine. So how do we, for people who maybe just heard me say all of that and are about to close this video, how do we convince them that maybe this isn't only an enterprise concern? Like, how can this be more approachable?
That's a great question, Jason, and thank you for framing it that way. When I talk about temporal at booths, I usually say, any kind of production scaling that you're going to have to do eventually, you're going to wind up having to solve a lot of the same not that fun problems later on in your deployment, whether it's failover, reliability, rollbacks, fault tolerance. Anytime you have one of these transactions that's not going to be able to complete end-to-end successfully, it might get you in like a weird edge casey state. And then you spend all your time figuring out exactly which edge cases you're going to hit in production because you didn't test it on like a flaky subway train because you live in Cupertino, you're never underground or
Right.
something like that, right? And so all these scaling problems that we all know we hit, every app winds up having to solve independently. That's not fun. Nobody likes to reinvent the wheel and be like, oh, okay, outages, you just have to do X, Y, Z, and pretty soon you're miserable. So Temporal pioneers this concept called durable execution. And what that does is it provides an architecture that you can build on out of the gate. And that way you can model all of these end-to-end database transactions, all these API calls as end-to-end processes that all do different atomic steps throughout. And every time your app will go through one of those atomic steps, one HTTP call, one database call, that'll automatically get persisted in log server side. So it turns your app into a state machine, if you like to talk about architecture. And every time your app goes through one of these little states, you automatically get that replicated and get that persisted. And if your phone goes off the internet or some of your client deployments fail over, they can just automatically pick up where it last left off. If you have to take something off the stack, you can do that too.
And so an interesting thing about this is, like in that example I was talking about earlier, where you hit two APIs. One of the things that is really complicated about that sort of thing is, like, in a database, if you're making changes, you can wrap it all up in a transaction so that if one step fails, you kind of undo all of the work that gets done. But if I'm calling a database or a service over API, and I'm calling another service over API, this change has happened unless I write the logic to make sure this change happens and then go back here and unroll it or do whatever the thing is. Now, this is the sort of thing that, again, just makes me immediately go, you know what? It's fine. Every once in a while that's going to happen, and I'm just going to manually fix it by logging into the second service and doing the thing. But this is something that again, like, kind of works, right? It just works out of the gate.
Yeah, I mean, that's what we say, right? It's nice for things to just work. People have solved this problem so many different ways, like you're talking about. Like, if you're lucky enough to have your entire application backed by one database, so you can solve that with just one database abstraction layer, more power to you. In the real world, not a lot of applications just talk to one database, right? I mean, if you look at modern SaaS, we're talking to 9 different applications at once. And so you can't really roll back those transactions unless you build in a layer to do that. And once you scale to a certain level, you can't just go in there and be like, oh, look, I'm garbage collecting, like with a literal shovel. Be like, see, it works. It doesn't work. So,
well, and so with temporal, this is one of the things that kind of blew my mind. So if I were to, instead of making these 2 calls myself in my own app, I put these into a temporal workflow.
Yep.
Then when temporal calls the first thing and it succeeds, and then the second thing fails, if I retry that workflow, it's not going to call this one again. So that it knows this change already succeeded. So it just holds on to the output of this so that it can run step 2 until step 2 succeeds. Is that correct?
Exactly. And that's when we talk about architecting for idempotence. So that way, when you're making that database call, if that database call has already gone through, it's not going to go through again. And so you can code in a way that's both safe and reliable so you can benefit from those automatic retries.
Yeah, I think that stuff is, like, again, this is the sort of stuff that, it feels like maybe this is only for really big teams. But again, if you're calling 3 services, and honestly, who among us for a side project right now isn't calling an auth service, some kind of data layer, and probably some third party other service, whether it's an LLM or some API that you're using for additional data, you are definitely calling at least 2 services, right? And immediately you're going to run into this problem where if the call to one works and the call to the second one fails, you need a way to recover from that gracefully. And I have learned firsthand that it is very difficult to manually solve these problems. Like I remember trying to write this stuff when I was at IBM, which is how I learned about things like Kafka and RabbitMQ. And it was really, really hard. They ended up hiring a team of specialists to manage that. And for me, as a solo operator, like, I can't afford a team. So we need a tool, right? And so the fact that these tools exist is really exciting. And the fact that I, as a solo operator, am able to sort of approach these things. But so there are a million things that we can use this for. Really, any step that we wanted to try. If we want to call an API, we want to make a database call, we want to do whatever. But I have a particularly silly idea today.
Go on.
So I'm working on this project, and I'll maybe keep some of the details mysterious, but we're going to unveil it at Render ATL. And as part of this, one of the things that we're doing is we're generating codes for people based on something that they're going to do. And once we get those codes, they are going to be able to claim those codes, which needs to, go hit a database and check that their auth is accurate and do a handful of things, and then come back, and it's going to be updating hardware, right? So we need to make some hardware calls. We need to make some software calls. There's going to be some network stuff. There's going to be some local stuff. And all of that needs to happen reliably on conference Wi-Fi.
Yep. I love demoing Temporal on conference Wi-Fi because I don't even have to make it break on purpose to show off the fun part. I was just at Google Cloud Next in Vegas like last month, and the best part was like, here's our agentic AI demo. Oh, it's taken a second. Hang on a second. And it went down. It just comes back up automatically. It's a beautiful thing to see.
Mm-hmm. Yeah, exactly. Right. Like, and I agree, Josh, this stuff is exciting. And so what Robert's saying here, there's a bit of a learning curve. And I think this is probably the hardest part about any one of these things, is because, you know, if you watched the episode of Web Dev Challenge, this was where all of the devs struggled, is you're basically entering something that doesn't have a real world analog. Like there's not, you can't like use some Legos and just show somebody what's happening. It's very much an abstracted concept. And so everything you're learning is sort of like, okay, well, you got to bend your brain into this shape to be able to think about how this works. So I think maybe the easiest thing to do would be to actually look at it. And maybe what we can do is just open up the source of this project that I'm working on and just kind of start with a hello world, like just get something real basic going, and then see how far we can get on maybe doing one of these validation steps or something of similar. We'll see. Like, I always feel like 90 minutes is so long, and then I'm like, oh God, we're already out of time.
This sounds exciting to me. Let's do it.
Okay, great. So let me take us over into, let's see, I gotta switch this over here. I'm going to switch this over here and just get a couple things set up before I share my screen. There we go. And that one. All right. And then I want us to be in this view. Okay. So this is Temporal. But before we talk about Temporal, I'm going to talk for just a quick moment about the sponsor of Learn with Jason, G2I. And so G2I is a company that is out to help you hire, right? Like, hiring is super hard. You get a lot of noise in the application process. Vetting an engineer is just super time consuming. It requires a lot of technical expertise, which usually means pulling engineers off of stuff that they could be working on that's a little more valuable for you. And it's just not in everybody's wheelhouse to like interview well. So G2I is solving this problem because they do the technical vetting on your behalf. They have live technical interviews. They are customizing their approach to each client's need to make sure that you're getting the right people into the pipeline for you. And it saves you a ton of time. And I've known the G2I team for a long time. They are actually in the community. They are, this isn't the typical like dear insert name here type of recruiter. These are really plugged in people who are really plugged into the community and actually know what's going on. So whether you're looking for contract, full-time, or even contract to hire, G2I can cover the needs of CTOs, product leaders, whatever you need. Like, you can get it through G2I. So go to g2i.co today and schedule time. You can discuss what your team needs. And also, if you are in fact an engineer looking for a job, go to G2I and see if you can get into the pipeline to be hired at one of these companies. They're great. I like them a lot. You should check them out. I think you will enjoy your time with the G2I team. So with that being said, let's get back to Temporal. So this is the Temporal stuff. We've got the link here to the website, temporal.io. Let me pull up the code here. So this is, let's see, this is the box. Let me close all editors here, and then we'll just kind of like close everything down for a second so we can sort of look at what's happening and then make a call on how best to start. So I have two apps. We're working in a mono repo today. Is this big enough? Let me make this one touch bigger here. So we're working in a mono repo. The way the mono repo is set up is we have two apps. This one we ended up scrapping and combining into this web. But we've got our heads-up display, which is going to be for the person operating the installation. And then we've got the web app, which will be for everybody else. We also have a couple of shared modules here. We've got a database. This is Convex, that handles things like generating codes, validating codes, keeping track of our inventory, et cetera, et cetera, et cetera. And then we have our hardware. This is the interface. We've got web MIDI going in a few directions here so that we can accept input. We've got a kind of like a touch interface that people are going to use. That's going to like capacitive touch, if you've ever heard of that. We also have some locks that need to be unlocked. We've got some lights that need to be turned on and off. All sorts of fun stuff there. So that's going to be some timed stuff. That's going to be a little bit of human in the loop stuff, which is pretty fun. And we've got a long ways to go. So, Alex, if you were coming into this app, which is somewhat functional, and you had to add temporal in, are you adding it as like a shared library? Are we spinning up another web app to be an API? Do we want to build it into the API of one of these apps? How would you go about it?
That's a great question. So what you can do is you can just pull down some temporal boilerplate as like an app framework, so you can kind of see that to compare against.
Okay.
I think that'll be a pretty useful way to do it. So if you just want to like get a new directory, I'm going to give you an npx command that you can run just so you can take a look at it right here. Then we can see how we want to plug it in. All right.
Okay.
I'm going to put it right in the comments here. I got to connect my YouTube to comment. My bad. Or I can put it in the private chat.
Yeah, put it in the private chat. I can copy it.
Yeah, you got it. All right. Right there. That'll give you an empty temporal app that we can pull up, and then we can take a look at it for comparison's sake.
Okay, so this is going to give us this is going to give us a temporal app. So that's running now.
Whoops.
npm has failed. Unsupported protocol.
You know what? We can do it differently. Hold on a second.
You know what? Why did it shouldn't have npm'd. It should have done pnpm. I don't know why it didn't.
That's okay. We can do it a different way. Here, you know what? We're going to try it a little bit different. We're just going to clone down a different repo so you can have a way to look at it. All right.
Okay.
Start by cloning this down in that directory.
Okay, so we're going back here. We're going to go git clone. And that.
All right. Hop in there.
This one, hold on. This one worked.
It did. It just said it failed. Maybe the post.
You know what? I bet it just failed because we didn't have. Let me just run the npm install here, and so now it's using pnpm, which should install everything, and then that'll let us.
Seems like it's happy with that then. All right.
Yeah, cool. It looks like it's fine now. So okay, so then right. For me to do this, we've got our.
It's just the one SDK library you should have to grab. But yeah, what that does, it gives you like some start commands, so that way you can deploy your worker and you can kick off a workflow. But those dependencies right up there where it says all the different temporal stuff, that's all you would add to a different project. So you got, temporal activity, client, worker, and workflow. Okay. Pull that in. Yeah. But let's take a look at the skeleton of this app for a start. So go up to the source directory. And for starters, just pull open that workflows.ts. Because this is going to show you the scaffolding of just a totally empty temporal app. And here we have, we're basically just exporting a function, right? So we're giving you a workflow to wrap your entire function in. It returns a promise, and it's totally empty. We can do whatever we want in here. Okay, we know what our workflow is going to call.
So the magic here then is that a workflow itself is just a function. The function accepts some input, and it returns some output in a promise.
Exactly.
And as long as that's true, we can do whatever we want inside of it.
Precisely. All right. Okay. So that's the workflow. It's going to wrap our entire application structure. Take a look at activities.ts next. Okay. Activities, same thing, just a function, right? And we separate these because our Python SDK does some cool sandboxing where it passes through imports, and we just follow that convention across the board. You don't have to have them sandbox like that, but same thing. You got workflows, you got activities. All it's going to do is call them. All right. Now take a look at worker.ts real quick.
Okay,
and
here comes
this is what actually runs the temporal code where it's deployed. And so in a proper deployment, maybe you've got a Kubernetes pod, full of workers. They all just run different temporal jobs as they come in. They can pick up workflows or activities and process them as they're scheduled on the server side. Usually you don't have to mess with the worker definition at all. You can just take that boilerplate and you can have your worker that's running somewhere and it's going to run. We talk a lot about edge deployments for cases like yours with the conference booth. And I think that's a really cool model because when I'm doing a demo at a conference, I'm just running the temporal dev server locally on my machine and running one worker with that singleton model, and that can work just fine. There's no obstacle to doing that. If you have a proper big deployment and what you want, you can actually just run part of the temporal service locally. So you can run it at edge, depending on what you're worrying about going down on you. And so that's a neat thing you can do.
So my trick is going to be that lots of people will be using their phones to kick things off. So if I'm running it locally, can the deployed web apps on other people's phones, they probably can't take advantage of a locally running.
I mean, it depends how you want to expose it, but probably you do want to have a full-on deployment. What you could do then is like run one of your worker matching services locally and have that tied to the box you're deploying. That way, you know you're never going to lose connection to that. There's a few ways.
Oh, I got you.
All right.
Okay.
All right. Why don't we now just kick off a temporal dev server just so we can see that running? Want to do that? Do you have temporal installed on here?
I think so. Let's see. Yes.
Cool. All right. Just for me, then all you have to do, and you can run it from any directory, is just temporal space server.
Okay. So let me start one over here.
Yeah.
Temporal server.
And then space start dash dev. No, that's not going to work on its own.
Start dev.
That's it. All right. And now kick open localhost 8233 like that. So you can take a look at it in a browser window.
Okay.
All right, so here is the temporal web UI. So you've got a temporal service running. A really cool thing is that our command line client, which you can normally use to interact with a remote instance, can just run a whole server out of the box. And we really like this feature for a conference demo. You can kind of run the whole demo off of a local server if you don't need third-party access. So if it's running all in one box, that's fine. And if you want to have a bigger deployment, we've got lots of Helm charts, Docker Compose, single binary instructions. There's lots of ways to deploy this larger. But right here, you've got all the component parts of a temporal service. It's running backed by SQLite. You have enough to work with out of the box. So that's your temporal service. You deploy that worker code, and all you would have to do is then just write workflows and activities, workflows being the big end-to-end transaction, activities being the component parts, and you're off to the races. So now that we've looked at that server, we've looked at the worker code, we've looked at the drop-in boilerplate, let's go ahead and add those dependencies to your app that you already have.
Okay, so let me show you the two apps that I have, and we can decide which one is the right one. I'm going to delete this this other repo before I forget why it's there. So the first one we have, this is what most of the people on the conference floor will be loading. It's a TanStack app. We are using TanStack router, and so if I can get back out here and pnpm run dev, and this is going to start everything. And so this will give us, that's our convex running. This is the TanStack app. So this is the first app here. So we go to our home, and I'm going to need to like uncomplete this activity so that I can I do that? You know what? Why don't we just add a new one? Because that'll be easier than me trying to do this again. So we're going to instead just add a new activity. This activity is going to, okay, so that goes away, and this is going to be new activity. So we drop that in, and then out here, because we are So out here,
it's very exciting. I'm seeing VIP ticket. I'm seeing render ATL. Like I'm excited about whatever this is.
Yeah, we got a lot going on. This is still pretty like proof of concept-y, but the way that it works is that when you find you'll get logged in, you'll create your account, and then I am logged in with clerk, so you can see we've got the kind of clerk thing going on. But then once you start your activity, it's going to give you some instructions. And at the point that you've completed them, you will do something like upload a photo or whatever the thing is, and then you will find an attendant who will validate that you did the thing. And they do that by scanning this QR code, or if you're already an admin like I am, you can go to the validation page where you can say they did the thing or they didn't do the thing. So if you did the thing, it validates. And then what we end up with out here is you have your completed activities. And then if I go to the, we've got our audit log going here. The admin, we've got like the prizes we're giving away and all that kind of stuff. And
Giving
then we
away
can
a
see
Switch
pending.
too. Very nice.
Well, if we can get one. But then we've got the dashboard, right?
Yeah.
And so on this dashboard, this is where the other app comes in, and this is the one that's running inside of the app. This one's running inside of the box, and so this one's running at localhost 4321. And so this one, I don't have my the hardware that would make this work with me. That's at home. Yeah. But what I can do is when I put these into box one, you'll see it's kind of updating. And so this is what the box operator sees. So my hunch is this is probably the one that should have the APIs, because this is the one that's sort of like the core brain.
That's my guess as well. But actually, you just showed something really fascinating in that last web. Like, go back to when you were talking about activities. And I think the context you brought this up, and it's not like a temporal activity, but rather it's an activity that you're going to have someone do on the conference floor, right? You said like upload a picture or whatever.
Mm-hmm.
And so I don't know if this is where you were thinking of embedding temporal, because I think usually we talk about temporal as like, well, it's going to make your API calls work. You know, the API is not going to go down. Your box will stay up, whatever. But a cool thing I'm seeing right here is we love to talk about using temporal to model any kind of end-to-end transaction. Or for example, you know, it can be like one person's interacting with this box, right? You got to track their progress through this activity. And at some point, it's going to get signed off on or not. But we have some steps, right? We have a nice end-to-end process, you know, like, so the way we often model this for like financial transactions or for like expense reporting is any kind of transaction that we have to get from point A to point B. That's a workflow. And that transaction is going to go through all these different steps. I see you've got a nice flow chart right here.
Yeah. So this is, and this may not be exactly right. But what we were trying to come up with is we've got like two pieces. There's code redemption, and then there's like activity completion. And so what I was picturing is 3 separate workflows, one of which gets triggered by a parent workflow. So the way I'm thinking about doing it is that when you go to do an activity, you would say, I want to do this activity. And so that kicks off a workflow, and that's going to do whatever the thing is. It's going to say, okay, you need to put in this information, or you know, like one of the ideas I had was we're going to hide QR codes around the venue. And if you scan 5 of them, then that completes the activity. So it's like we need to wait for successive calls to this API until the count hits a certain point, at which point the activity then goes to the next phase, which is complete. So it has some kind of a validation step that says, here's how we know whether or not this thing is complete. That returns a success or failure. If we get a success, then we open up the code generation workflow, which would go off to the database, say, create a new workflow for this user, attach a random prize to it, you know, make sure that the prizes are in stock and hold them in inventory, all the things that we need there, and then bring back the code for the user so that they in their app now have just a list of their claim codes. And then up on this side, we have, this one's a little more complicated. The attendee will enter their code, and that's like manual on a keypad. The workflow gets started when they submit the code, like press enter, kicks off the workflow. That'll turn on some lights in the box, at which point we have to go hit the database to see whether or not the code is valid. If it's not valid, we need to flash the error light for a couple seconds and then reset to our default state. If it is valid, then we need to update the interior prize screen and say which prize goes into which locker, because there are multiples. And then we have a human in the loop step where the person who is operating the box has to actually load it and then confirm it's actually there, which triggers the lock to unlock, which pops the door open. And then we have to flash some lights. We need the person will actually remove the prize, at which point the person inside the box is going to make sure the door is locked or like pull it close and then hit the complete button, which does some light things and then updates the claim code as like this one's been retrieved. And then goes like loops us back to the beginning, right? So there's a lot that needs to happen. And this is why I was thinking temporal would be great for this, because there's, I have to talk to the hardware on the device, and this is, multiple Arduino or Raspberry Pi devices.
I was going to say, how many Raspberry Pis are you buying for this thing? Like, this is some mad scientist stuff. I love it.
It's a few.
Yeah. And, you can do anything with GPIO pins. That's what I always tell myself, right? It's just, I love just having a device where I can simultaneously have like a little Python server running or whatever, or an Express server. Right. And then it can just trigger a GPIO, whatever, right? To unlock a latch. Like, the escape room design is basically just that over and over again. I think being able to think about, like, how do I get from a web request to a hardware lock? It's not complex, but just so many people don't think about hardware that way. So I love doing this kind of stuff.
Yeah. And so the way that we manage to solve this is we're doing web MIDI. So each of the touches sends a web MIDI request, and then we're just kind of coding this, this MIDI address is this key, key code, so that we have a 0 through 9 and then a enter cancel, right? Those are the ones we need. And then we can also send web MIDI for each of the success, pending, and failure lights, as well as the lock. So it's all just web MIDI, which is great for me because the API is super straightforward. And from a workflow standpoint, then the way that this ends up working is it's just a series of API calls. Like, I call the web MIDI API to send a number or to receive a number. I call my database API so that I can update or retrieve or whatever. And if we just kind of patiently string each of those steps together, none of these steps in isolation is hard. It only feels really hard when you think about, oh, well, somebody's going to punch in a code and then all these things happen and the door unlocks and there's prizes. It's like, well, yeah, sure. That's hard. But like, each individual step is very straightforward.
All right. I have to ask you a question. It's a total sidebar. Are you familiar with phone phreaking? Have you ever heard of that?
No.
This is apparently how Steve Wozniak got his start before he started working for Apple and, putting his talents towards making money before he was, actually met up with Steve Jobs. So apparently back in like the Bay Area it would have been like the late 70s, people figured out how to hack the phone system. If they could like make the sound of an 8-tone or make the sound of a 6-tone, right? They could actually tap in to what should have been like a closed circuit that could only make a fixed series of responses, right? Because if you're looking like web MIDI, that's just a series of tones, right? They're all hard-coded, basically, but they're all just different intervals. And so it is totally possible that you could have, somebody in the loop, hacking your web MIDI system, figuring out how to send like a fake 788 or whatever you have to get in there to dial in. Yeah.
And this is sort of like, we were trying to think through some of this stuff too, because, how do you make it so that if somebody gets a code, they don't just like tweet the code and then everybody comes in and puts in the same. So every code is generated on a per user basis. They're all globally unique. They're single use. And all of that is just more steps that we have to perform, which is why this starts getting, so it starts feeling very overwhelming when you start to look at this is not a small amount of things, because each one of these things is a reasonably significant piece of business logic. So it's stringing all this together in a way that is resilient. And like, if this one screws up, I don't have to worry that all of this has just broken this code and like, this will never happen unless I go in and do it manually. Like, I don't want to have to sit at this booth all day babysitting it. I want to trust that it's going to run. Right.
Yeah, of course.
So
I have one more comment while this is on screen. If you go back to that Figma for just a second, or ARC, sorry. The fact that you have called this activity workflow is going to make every single temporal architect cry to pieces, just because like activity means something very specific in temporal, right? Like an activity is all the component parts run by a workflow. And so just like saying,
so we'll have to rename this task.
Yeah, it's got to be a task workflow. And the component parts are all called, those are all the activity calls, right?
Okay,
Just
so we'll
something
we'll
like
call
that.
this
Yeah.
we'll call this task so that it doesn't melt everybody's brain here.
Yeah, I
So
think that's
yeah,
going to
and
be best that way.
naming things is tricky because I also had a problem where it's like, well, we've got the box, and then we've got conference attendees, we've got box attendants, we've got right.
Yeah.
It's like, oh my god, words are extremely hard.
We're saving lives here, like not all heroes wear capes is what I can tell you. It's just very important to be able to disambiguate things very importantly.
Where can we learn more about the app I'm building? So this app is currently, once we go live at render, I will do a little more of a deep dive on like what this is and how this works, and probably a bit of a post-mortem on like what I could have not spent time on and what I should have spent more time on, because I'm sure that's going to be the case. But right now it is very much this stream is going to be the most context you can get on it. Alex was made for camera. I agree. Okay, so to make sure we have plenty of time here, because we got about 45 minutes left, why don't we let's get rolling here. So you said go into we need the dependencies.
Yeah, out of that
and
package,
it was these
Jason,
4, right?
Yeah, just grab all those, and those are pretty reasonably recent. Yeah, 1.11.8 is okay. So just go ahead and grab all those. You'll be happy with those.
All right, so I'm going to throw these in here. I'm going to stop this. We're going to npm install again. And then we will npm run dev again. Oh, if I can spell it right.
Yeah.
I hope the leaf blower in the alley is not coming through.
Just for a sec. I mean, my cat was trying to get up for most of the last 20 minutes. So, streaming is always very dangerous.
Right. Okay. So then I have, so basically I've got file-based routing here. And one of the things I can do is I can either make server-side routes or client-side routes, depending on what is easiest. My guess is we want it to be server-side.
Yeah, so this is a great question. So what we use in Temporal, like our primitive for sending any kind of input to a running workflow, is something called a signal. And you can send a signal from our command line client, and you can send our signal just by pulling in a tiny little bit of the Temporal SDK guts into any other application, and then giving that application the ability to send temporal client functions like signals. And so
my hunch here is that what we want is to have people send an API request, basically, like hit an API endpoint that'll kick off the flows.
Yeah. And so one of the things you use a temporal client for is to actually kick off a workflow at the start. And so what you can do is you can give one of your applications the ability to kick off that workflow, and you can give another one the ability to just send input
signals
to a
into
workflow
it
once it's already running.
Okay. So do you use one endpoint and sort of route internally, or do you set up separate endpoints per thing?
It's all gRPC. That's one of the beautiful things about temporal SDKs, is basically like we talked about at the very beginning of the stream how everything just becomes queues the whole way down, right? Like everything is, RabbitMQ, whatever. But all the temporal SDKs just work over gRPC, which means you have to expose, 7233 for gRPC port feedback. But the really nice thing about that is everything that your server side worker is getting is just all being sent over gRPC calls.
Okay. So structurally, like for the web app, how would you architect this? Are you creating multiple endpoints that are all like each one is sort of doing a different thing? Or are you creating like /API/temporal, and that's sort of where every call gets sent?
That's a way to do it. You could do /API/temporal basically, and then every single one of those web endpoints would send a different signal up to the running worker, right? Is that how we're thinking about this?
Yeah. So I'm guessing the way that this will probably end up working is we're going to have like an activity or a task that somebody's going to start. And so they would, upon doing that, they click that button. That button is probably going to hit /API/activity with an activity ID and their user ID, which is how we would then say like, okay, create the in progress activity, do any of the other things we need to do.
The fact that you
And
said
then
activity again, I'm not even going to mention it. You know what? I'm just in my
I'll
head.
retrain my brain.
I got this AirPod. I've reprogrammed it during our call to just not hear the word activity there. You couldn't see my hands. That's what I was doing.
Okay, so why don't we start there? Let's start
Yeah.
with that. We want the ability to have somebody kick off a task.
Yeah. You want to be able to kick off a task.
So we'll make the API/task endpoint, which is going to accept a task ID, and the user will call it with their clerk ID. Like there'll be some headers or something that we can get.
That sounds good to me. I'm gonna give me to paste in here for you some sample code, or how do you? I can just tell you how to get started.
Yeah, why don't you just tell me how to get started? I think that'll be nice and easy.
All right, you're gonna want to import connection and client in curly brackets from temporal.io/client. So connection and client, and you should, yeah, there you go.
Okay.
All right, and then you're just gonna want to do like we'll say async function run here, and
so the way that these ones work is we have to export async function. These are serverless functions, so we just export the method.
Okay.
And so this will get run whenever somebody like hits this endpoint.
Hits the endpoint. Okay, cool. That should work. All right, so let's do const connection equals await.
Oh, await.
We're gonna do an await here, yeah. And we can change it later on to make it, but let's just do out of the boilerplate. Connection that you imported already. .connect should be a method, and that's going to go in brackets. So some pseudo JSON to address, and that's going to point at wherever your temporal instance is. So if it's running locally, we can say it's on localhost. Otherwise, you can bootstrap it with an environment variable.
Let's do the environment variable, just because that's going to make life a lot easier. And this one can be client. We'll leave it client public for now. And there's nothing sensitive in here, so we'll go temporal URL.
Exactly.
And that is going to be this one or this one.
Yep. The 7233, the gRPC, not the web.
Okay.
Yeah.
With or without the protocol?
Without.
Okay.
Yeah.
All right. So we've got. I'll stop and restart to pick up that environment variable. And then that means in here, we're going to use the temporal URL, which will come out of the Astro environment. And then what else?
All right. So now you've got your connection object. So now we're going to create a client object based on that.
Oh, we don't need any other options. Oh, nice. That's easy.
No,
I thought we were going to get into like API land.
Is really nice and clean. Yeah.
Okay.
So now const client. And that's just going to be new client with the connection object passed to it as the only argument.
Got it.
And there you go. All right. Now we're going to show what actually kicking off a workflow from one of these client looks like. Okay. So you're probably going to want to put that execution in an object. So we're going to do const here. You don't really have to pass it to an object. We're just going to say, my task workflow or something like that.
Okay.
Okay. And we'll do an await call for now again. So await client.workflow.start.
Okay. And that's going to take our workflow function, which I imagine we're probably going to declare somewhere else.
Yeah, exactly. And so with that client, you're able to dispatch a workflow like this. You can pass some arguments to it right here. So we'll just kind of leave this boilerplatey for now, but basically any arguments that you need, like a generated UUID or anything that you need, if you don't want that to come on the temporal side, if you want to bootstrap it with like this workflow is inheriting special parameters, you can do it right there. But basically that is all you need to then just kick off a workflow for the very first time. And then that workflow will run with whatever you bootstrapped it with.
Got it. Okay. So then for us to do that, I'm going to just stick them all in here in this lib folder.
So, yeah.
Then we want workflows. And so my export function, task workflow, and that is going to return a promise with something. We'll figure that out later.
Yeah, and
And
you're going to want to
then-
do some imports at the top. So just here, based on what we already had you grab, I'll just paste you again in the back end. You can stick that in the very first line of the function. That way you've got all your calls pulled in so you know how to properly decorate. So you can just stick this to the very top of the file.
Okay, grabbing that.
Yeah.
Okay, so we've got proxy activities, log, define signal, set handler, condition, and we've got application failure. What are you mad about? Cannot find.
Oh, we didn't grab common. We might have missed common as one of our imports. Yeah, we did. Go back to the package, Jason.
Oh, got it.
So just in addition to client, just grab common, and it's the same version string. There you go.
Okay. Oops. Okay. So now we've got those. And so this is like the basic that you were talking about, where it's just a function that returns a promise. Where does all this come in? Like, what are we getting out of this?
So these are basically all the things that your workflow can do to respond to input, or to send some errors back up, or to act on any kind of conditional stuff. Because we talked about, we have some endpoints that are just going to send data to our temporal application, right? That very first endpoint that we defined is just kicking off the workflow. But for any other human in the loop type functions you want to build in, like anything else you want this workflow to be able to handle while it's already running, whether it's an approver or what, those are all going to be handled through signals. And so what I imagine you're going to wind up doing is, like, apart from the one endpoint that actually kicks off a workflow, every other endpoint you have is going to be sending signals to your running workflow. And so part of what those define signal set handler do is that they let your workflow respond to signals as they come in.
Okay.
And all this stuff, I mean, you know, it sounds like I'm just making an API call, but what actually happens when you send a signal, that signal file server side, it automatically gets logged and propagated down to all your running temporal workflows. So it's like, our signals are ridiculously robust, right? It's one of those things where, like, it seems over-engineered until it's not. And so the way we have all these endpoints built out is that way those signals can all get persisted and logged against any running workflow.
Got it. Okay, cool. So so then maybe the way to make sure we get through at least the conceptual stuff is, let's just hard code some values, but let's add a sort of human in the loop thing here. And maybe add an API call. So maybe what we can do is let's start, we'll just get a workflow going, and then let's have an activity that loads, I don't know, just our active inventory. Why not? And then we'll have an activity where we have like a human hits an endpoint. You know, we can say it's via button, but we'll do it probably through curl that just like continues and completes the workflow.
Okay. I have some ideas about how I want to do this. This sounds really cool. So the first thing I would start with, we just looked at your client root. Why don't we do one more client root? Because we just have that fresh in mind still, and we can have that send a signal. Because I think that'll be a nice way to define one more endpoint, so we can just see what that looks like. Okay.
Okay. So let me duplicate this, and
duplicate that exactly.
I'm just going to call this validate. And we'll do whatever with it later.
Cool. Get rid of that very last line, because we're no longer starting a workflow. Okay. We're going to be sending a signal. Okay. And the way to do that is we have to get a signal handle first. And what you can do is, if you already have the context from the same client, you can just already have the handle from that same workflow instance. But if you have to then get the handle from a running workflow instead, you can call something called get handle. So const signal handle equals client dot workflow dot get handle. Yeah. And then you would pass it the name of a workflow that you know is going to be running with a particular UUID. So probably you hit this endpoint with that, you know, workflow that you already want in the signal, right? So,
right. And so we can probably fake that for right now. Because can I manually set the UUID when we start the workflow?
Yes, you can.
Okay,
So
so
just
does it have to
so
be
like
a UUID, or can I just call it like
you can do like my
ABC
dash
for now?
name. Yeah, that's totally fine for now.
Okay, so we're
That's
so
okay.
while
Yeah.
just to prove how this works and not get into the nitty gritty of like generating IDs and stuff,
Yeah, yeah.
let's just do this, and then
Yep.
I
And then one
can.
more line. You're gonna actually then call that. You're gonna use sig so await uh, signal handle that you just set up dot signal. And
Okay.
then basically at this point, we're just sending the name of the signal that we want to that we're going to declare in a second. So validate exactly.
Okay.
And you can pass additional arguments to that. So you can have signals take names. They can also take arguments. But basically, that's what that looks like. Okay. So
Okay.
now we have two different endpoints, right? We have one endpoint that we're using to kick off our workflow in the first place. That's going to inherit some amount of information. And now we have it dispatched. We got it running. It's registered server side. And we're going to have one more client that's going to actually send a signal. And yeah, you can just do like a console log, you can return that, whatever. But here is how simple our routes need to be. They just need to have that enough temporal client boilerplate, so that way they can then hit the server and do something. So pretty much this is what our routes look like.
What are you? Oh, you're mad because we don't have our
The
actual
right number of
workflow yet,
arguments past the start.
but we need to finish this workflow first.
Yeah,
Okay.
so we'll get there. All right, cool.
Okay.
All right, so now
we've
we
got a
have our two
signal, we've got a
endpoints. We
task.
know what those are going to look like. Pretty good?
Mm-hmm.
All right, awesome. Let's go back, and before we define our workflow, let's actually write an activity, because activities are more or less just pure functions, and then our activities are going to actually get called by our workflows. All right.
Okay. So async function. The first one is going to be load items, and that's going to return promise. You know what? Let's let it just infer. I think that'll be fine. And then we're going to return to start just an array of the prizes that I will grab out of here.
Yeah.
And that'll make life way easier than like I would like to get in here and actually make this call, but we're not going to stress about it right now.
Yeah. And this, again, like the nice thing is activities, you're just writing pure functions here, right? It's like doing any other kind of app development. The only difference is these are going to get called in different ways by the workflows you set up to frame them.
Yeah. Okay. So we've got our bits here, and that's just going to be returned by loading the items. This will all we marked it as async, so it'll automatically get wrapped in a promise. So that's fine. Anything else with this one, or can we just sort of leave this as a?
There's nothing else you really have to do out of the box to mess with your activity. I mean, one thing at some point is like, how much data are we passing directly back and forth from workflows to activities? Because a cool feature of temporal that we haven't talked about as much, but we were kind of hinting at earlier, is that depending on how much data you're actually like needing to read and write as part of a temporal workflow, you don't really need to add a separate database layer, right? If it's a small application, a really cool feature of temporal is where you'd normally be like, writing to Redis or constantly reading and writing from a database, you can just pass data directly back and forth from activities to workflows, because everything that goes into a workflow is durable and is effectively persisted. And so it's a really neat feature. And we do put, like some threshold on like how large you don't want to just pass enormous binaries back and forth across temporal active, but like if you're just passing some JSON like most web apps are, you're not going to hit the threshold beyond which there's performance issues. And that makes temporal really neat, because you can just engineer the database calls directly out of your application.
Okay. And okay, if you are feeling like these concepts are steep, please stick with us. Don't click away, because when you actually see this operate, it starts to come together. Like there's a little bit of boilerplate here, but that's for a reason, because we need these to be atomic and well defined so that they can be automatically retried and durable and all the benefits that we want. So don't give up on us just yet. Stick with us here.
Yeah.
Robert, I'm going to answer your question.
Interesting question.
Oh, you want to take it now? Yeah, let's do it.
Yeah. So a really good point Robert is making is, okay, we're now letting our web app directly send signals with a temporal client to the temporal server. And yeah, it's like, how does that security model work? Because that sounds potentially fraught, right? We just have an open gRPC endpoint, and I don't know if you've ever secured gRPC before, but like most people do not build like additional SSL stuff on top of gRPC. You can do it. It's not that widely done. Most of how we would do this at that point, depending on how you're engineering and deploying your temporal app, is the best way to do it in most production deployments is just like a lot of WireGuard rules, right? Where you've just got protected routes and you've got one client can make these calls based on where it is in your deployment and your architecture. We encourage people to just use protected routes because SSL gRPC is kind of gnarly. You could have like a back end to front end. Yeah.
So what we're doing is we're basically making a back end for front end. We're standing up an API. You have to be able to hit that API, which I can authenticate over standard HTTPS, SSL, usual OAuth stuff. But you can also put the client directly into the front end. But when you do that, you need to make sure that that client is only accessible to somebody who is properly authed. So like under a protected route.
Yeah.
Okay, perfect.
Cool.
Excellent.
Great question. We appreciate that.
So let's see if we can get this thing going. So we've got our first activity, which is going to be loading the items, and then our second activity is going to be validate, which I think we can probably just kind of hard code a true false. Yeah.
Yeah. For now, I mean, we just want it to return something, right? Just to show it working.
Let's just have it return true, and then we can come back later and return false to break it.
All right.
So, okay. So these are our activities. The first one is to load items. Second one is to check whether or not the person did the thing that they said they were going to do. And that is going to be done through a human in the loop check. So the workflow will just pause until I or some other admin on the project actually hits the button that says, yes, this thing is valid.
Yeah.
Cool.
All right. So we're doing great. We got our client routes done. So we know how we're going to kick off our workflows and we know how we're going to signal them once they're already running. We have our activities written or at least stubbed out. We have some pure functions that our workflows are going to call. We can now go ahead and like put our workflow definition together. So
let's do it.
We're getting there. Yeah. One thing you're going to want to do is put together some retry rules for your workflow. So that way, you know how you're going to be calling some of the different activities that your workflow is going to call. Okay. And so let me see, before the actual workflow function. So in between the imports, let's just do, what's the best way to do this? Hang on a second. Send mail, get distance. We'll add that afterwards. We'll come back to it. All right. So in our workflow definition, I think when we first kick off our workflow, are we going to be waiting for input right away? Like, are we going to be just like we kick off our workflow?
I think let's not. Let's start. Our workflow starts and immediately loads the items, and then it waits for the validation step, and then it will complete.
Okay, that sounds good. So it's just going to run an activity, right?
Well, it'll run two. Like it runs one, waits for input to do the second, and then we'll complete after the second is done.
Yeah. So we'll run the first one, then we'll wait for a signal, then we'll run the second one.
Yep.
Sound good? Okay. Excellent. So what you can do, I mean, first you can set up any variables or any other just kind of bootstrapping you have to do, but then what you can do is literally just call that function.
Okay. So we're what do we call this one? Load items.
Load items, you can just, await, call to function, and then just throw it in a variable. Yeah, exactly. You can wrap that in a try catch if you want, and temporal is pretty good about like a cool thing about writing with temporal. One of the things we do is we automatically replace a lot of language functions with durable versions of them. And so one of our favorite examples is like a sleep call. Normally, if you just call sleep in a language, it's just going to wait, 3 seconds. It's going to wait on that client. It's going to wait on that thread, whatever.
Sure.
In temporal, if you call sleep, then that actually dispatches a timer up to the service. And if your client goes away while that timer is counting down, nothing will happen because the timer is tracked server side. It'll wait for a new client to come online and be able to inherit that timer and then run whatever gets kicked off by this function.
Okay.
So we
Cool. Very
basically
cool.
make a lot of your basic code a lot smarter and more durable just because
So
you're
does
using
that
those
mean,
temporal function calls.
so you talked about a try catch. So are you doing something that will automatically try catch this?
No, you can actually just wrap a try catch in there. So what'll happen is we do automatically have a try catch. So the answer is like yes, kind of. If you don't do a try catch, you will get the benefit of our retry policies, and
Mhm.
we're going to define those right now. So
Okay.
up out of this function, out of this workflow block. So between the imports, yeah, let's do constant, and we're just going to put in brackets the name of your function call. So load items, but in brackets, like it could be a list. Curly
Okay.
brackets, sorry.
Oh, got it.
Yeah. Because
Oh
all
boy.
of our activity calls are going to be going here. You can actually put load items and validate. How about that? We'll do 2 of them in a row in curly
Oh my God.
brackets.
There we go. There we go.
There we go.
There
We
we go.
got it. We got it. Hey, you're good at doing this live. There you go. Yeah. And then that's going to equal proxy activities. And then left caret, and that's going to go type of, and then activities. And then right caret, and we're going to open up parentheses and a curly brace, and we're going to define some cool temporal constants. So for example, the one we always have you assign is start to close timeout.
Okay.
Start to close, schedule to close is something different. We can explain that.
Oh, my bad.
That's all right. There were a few options there.
Start to close timeout.
And you're just going to set that to 5 seconds instead, like actually just, single quote 5 space seconds. We can parse up the string for you. There you go.
Oh, no. Okay. I was about to say, like, okay, is this milliseconds? Is this actual
No,
seconds?
you just literally write 5 seconds. We like to make some things easy. It's a complicated architecture, but once you start working with it, we make it simple. And then you can also optionally set like a maximum interval for retries, but you don't have to do anything else right now. So we can just leave that as it is right now. And this can be your whole. Yeah,
okay.
That can be enough. And so
now,
what that
we've
gives
created
you,
a naming collision here.
Yes, we have.
So do I need to make this activities instead?
What you can do is we usually do import type asterisk as activities from activities.
Come on, which one of you is
asterisk?
you?
There you go. Yeah. So that's typically the convention we work with to fix that. And so what this does really nicely.
What am I doing wrong? Why is this mad? Cannot find.
Activites.
Spell. Can't
There you go.
spell. That is a
it.
lot of the problem happening right now. Got it. Okay.
So the what that does is this is like the automatic try catch that we were talking about, right? And so if you don't wrap that call in try catch, everything will automatically have the ability to get rerun if it doesn't return successfully or if it doesn't return within 5 seconds. Now, out of the box, that'll make your activities all retry indefinitely, which is really cool some of the time, but it might not be what you actually want. And so if, for example, you're trying to fail on bad data, or you're trying to fail on like actually a failure case as opposed to just an outage or something you want to be able to retry automatically, that's when you'd want that try catch, right? And so you don't really need it here because we're not thinking about a way that we're going to fail this. So we can just get rid of it. But I hope that was a cool way to frame that so you can kind of see, like what's an automatic retry versus what's a case where we actually want to handle some bad input and then
got it.
Out. Yeah.
Got it.
Okay. All right. Okay. Now, between our 2 activity calls, we're going to handle that signal, right? So we're going to call, we're going to write, so let's do set handler. I think the H, we should have that. And then it's going to be the name that you want to give that signal.
Did I already call this something? Let's see. No, it was validate.
Yeah.
Okay.
So you can just call it validate signal.
You're giving it like a.
It doesn't have to have the exact. Where's the name set? So the name that actually gets set would be fulfill order signal. Yeah, give it the same name. Give it the same name here. You're right.
Okay.
All right. Validate. And then comma. We're just going to basically set up an object for like is validated. Is validated. Yeah, is validated. And then you can assign that. So like equals caret.
Wait, hold on. I'm doing something wrong.
Here, no, let me send you some boilerplate right here for how we usually do it, and we're just change it to reflect this. So
Caret,
copy
like,
that in, because that's kind of how we normally do it. And then basically we're going to do this right here.
okay,
So
where is this
that
signal coming from?
So that's going to be coming from that's the client that you set up to run this signal, right?
Where did we set up a client to run the signal?
Yeah, so you have the client which is able to run that validate signal. That just matches the string name in effect.
But yeah, but how is it?
So right, sorry. Yeah, we have to export it up top. No, you're absolutely right. Throw this in outside of the workflow itself right here. And again, we're going to change the name of it afterwards. But right after that proxy activities block, but before the actual workflow definition, throw in that export constant. Yeah. Right there.
Okay.
All right, cool.
And so this is going to be validate signal.
That's going to be validate signal.
And
exactly.
This is going to be validate.
Yep.
And then this will be validate signal.
Exactly.
And then we get back whatever we want.
Yeah.
And so his order fulfilled. So all of this is just sort of like whatever I want it to be.
Yeah, you don't need order. That's basically them. This is a different app that actually has like a whole order object. So you don't actually need all that stuff. You basically just need a variable that you can wait to be set to true.
Okay. And so is valid I can leave out then, and we can just like set some variable.
You can just set some variable. Yeah.
Like
exactly.
That.
Bingo.
Okay. Why are you mad? Oh, because I can't spell again. Jeez. Okay.
There's worse problems to have. We're doing great. All right. Cool. All right. And now we're just going to like await condition, signal processed is true.
Signal processed.
And you can do it like however you want is true.
So this is a function. Like, so we need.
So you can just do like a little empty parenthesis. Exactly. Bingo.
Got it. And then we're going to do one of those.
Yep. And then
after that, we have the second thing.
After that, run your second activity.
Oh. And that needs to be awaited. And then we're going to okay.
Cool.
Nice.
So we're missing some logging, obviously, and we're just kind of returning some strings here and there, but that is a workflow definition that includes a signal in it. So we are most of the way here.
Okay, so then just to show that this is working, we will give them items dot at 0 dot name. Okay, so that way we'll get a prize listed, right? So now we've got a task that kicks off. We've got a workflow to handle that. This loads the items. It'll end up being from the database, but for now it's just hard-coded. We then wait for someone to do a thing, and we're wanting someone to validate a signal. So then this await just pauses the workflow. And when we say pause, it doesn't mean like it's just spinning indefinitely. It like actually does something magical where like on the temporal side, it just sort of like goes dormant and says, okay, I'm not going to do anything until the signal arrives. At which point it will wake up, run this call, and then come back here to actually do the thing and return a final value.
Exactly. And it's like you said, like all of the individual clients are basically stateless, right? Because temporal's architecture is that any one of your clients can go away, your workers can crash, people's phones go offline, whatever. All the state is tracked server side. And that way, if any client ever comes back up and there's a new task waiting in the queue, it'll get dispatched to that new client automatically. So yeah, it's not blocking. It's basically just saying like, I have no work to do for this workflow until I get that signal coming in from somewhere.
And it's with the log, do you just like throw whatever you want in here?
Yeah, so one of the cool things is I was talking about how temporal kind of like quasi decorates your code in the background so that your sleeps will automatically turn into timers on the server side. Our
Did you just freeze or did I just freeze? Oh no. Oh, if Alex is out, we are cooked, y'all. But actually, let's see. Let's see while we wait for Alex's stuff to hopefully come back. Okay, Vanessa can hear me, so we are. You know what I didn't mention, y'all, is we have captions. I don't know why I didn't talk about this already, but we've had Vanessa here from White Coat Captioning doing the thing all day. So if you want to go see the captions, go check them out. That is done by a real human. Feels rare these days, but it is delightful. So let's do this. Let me see if I can make this thing work. So I'm here. I've got my API. I'm going to go to API task, and that's a GET request that has no arguments. So theoretically speaking, what will happen? This is a 10,000 foot if. I'm going to run this, and it's going to do nothing because why wouldn't that work? Did you die? No API route handler. Okay, I'm gonna look up what is going on with this. Astro endpoints. Oh man, this is going to be an exciting ending because we're going to find out whether I remember how code works at all. Return new response. Export function. Yeah, dude, I did this. Export async function get. Yes. Return new response. Return new response. Oh, we didn't actually do the workflow. So I need to bring in this workflow, which is called task workflow. So if I come back in here and I do one of these, and then I do one of these, you're not happy. Expected 2 arguments. First argument is, what's this? An argument for options was not provided, which I'm just going to do it. No, can I not get away with that? Workflow ID. Oh, right. This is the one that I'm going to say ABC123. Don't give me that. Workflow start options. Task queue. I think that was called default. And my reasoning for thinking that is that in this oh, Alex is back. Oh, thank God.
Hey, exciting cliffhanger. That was amazing, by the way. I missed whatever you were doing for the first 90 seconds, but that ruled.
How am I doing here? So
You're doing amazing. Yeah. So I was about to say the one parameter that we're missing to be able to kick this off is just defining what task queue we're going to run this on. And we need a worker, basically. The one thing we haven't done yet is supplied a worker with this app. And
so we need a worker. So let me get up in here.
And you can copy that from the boilerplate I had you clone down earlier, because a worker is pretty much boilerplate. A worker is just like a temporal client implementation that's just going to run your code. And we talked about how workers are basically in production meant to run in like Kubernetes pods, but what you can do if you're just running like a one-off is you can just kind of deploy them on the command line, and that's really helpful for local development. And the one thing that we need to define in our worker is all the different task queues and workflows and activities it is allowed to run. Because you think about it, if you got a big temporal deployment, it's running lots of different kinds of workflows and activities. The way you allocate capacity and the way you handle load is you just deploy more pods full of workers to run certain activities or certain workflows on certain task queues. So You want to make sure, we usually use a shared constant, to have the same task queue name, so you're not just typing it in multiple places, but this is a
Right.
perfectly good way to do that. So let's just make sure that we're running everything on the same task queue.
Okay. And does it matter? Just call it task queue.
You can just call it task queue. That's okay. And then if we scroll up to the top of this boilerplate, what do we have here? So we're doing import as activities from activities. You probably already saw that. That should work fine, right? Because we're telling it we can run all of our activities. So we scroll down, and you see here activities is one of the parameters given to that worker. So it just knows it's allowed to run all the activities, and it should also be allowed to run all the workflows. And so this is a pretty decent way to just hard code paths in. Like I said, if we're not doing like more fine grain, what are you allowed to run? Okay, it's good.
Okay.
So as long as that task queue variable name matches, so I think you got the task queue mismatch here. You got task queue called default in one place and not the same.
Oh, right. Task queue, not.
Yeah.
Okay.
You would be surprised how annoying that is if you're just setting up like demo apps just like this.
This is one of the ones that I think this caught Nick in Web Dev Challenge.
Yeah. If you just, there's no workers to process you, and we've added in the web UI more and more like, hey, you have no workers running, but it's just one of those things you're not going to notice.
Okay.
Right. So
now that
you should now pretty much have enough. What you want to do is you want to kick off that worker. So the worker should just be running somewhere.
Hold on. Did I need to set up that task queue somewhere?
Nope. The task queue gets instantiated just by the name of itself. And so basically these are like everything in temporal is transient unless it's the server itself. And that's a great rule. So, all you need now running is you want your temporal server running, which you already have. You got that running, and you just want to run your worker. So we want to kick off our worker somewhere else in the background. And usually we can do that with like npm run start.
Oh, wait, it did a thing.
You ran the endpoint. Click through on that workflow ID. See where it says ABC123?
Oh, ABC123. Here I am.
So we have a running workflow. We kicked off our workflow from our endpoint. Our worker is not running yet, but this is exactly where you should be. And this is telling you that we've got a workflow dispatched. This is really cool, right? We kicked off our workflow. Temporal's working. It just doesn't have a worker ready to actually process the work yet. So all you have to do is just run an instance of that worker somewhere, like an additional terminal. And
and for me to run this, is it just a node process?
Yeah, it's just a node process. So what we would typically do is just, assign, like npm run start to just kick off your worker. Sometimes we use ts node. Basically, it looks like this. It can also run nodemon, but I'm pasting in the private chat right here. And we would just assign that to like a start, and that way you just have the worker running. So it should work to just do ts node.
Oh, I don't have ts node.
If you have nodemon should also be able to do it for you.
I don't think I have any of those installed locally. What do you mean that doesn't work? Okay, let's do. Now we're fighting. Okay, so was it just brew install ts node?
Or we can add it to our dev dependencies in the package JSON and then npm I it.
Well, that would have been a good call.
Yeah, that might be easier. So just basically like go back into our package JSON and we're good here.
Okay, so we're going here.
Add a dev dependencies block. You can put it in the regular dependencies too. Just for now, it's okay. It's not going to hurt anybody.
Dev, and then just ts node.
TS node.
And I'm just going to star it because YOLO.
Yeah.
pnpm npm install. And then now if I npx.
Or you should be able to just run ts node as is, just kind of like go back up through your command history.
Let me get into this app then for me to do that. This is the Box HUD. And we're going to run ts node. And it's still not working because...
Oh, you know what? You might need... No, that shouldn't be necessary. It should just run as is.
I think this should just... It should just grab it out of the thing.
This is my least favorite part of trying to bootstrap
module not found.
Oh, okay. Here we
Cannot
go.
find module temporal activities.
Oh, it's just the import path. Seems like we didn't quite get it because we've like, let's see,
Where
where's
do you
our
think it
worker
is?
relative to our activities?
Should be right next to it. And you are
Should be right next to it, right?
worker activities. Import as activities from activities. That is right where it's supposed to be.
Yeah,
So where
that
do you
looks like
think
it
it's
should be
running
good.
from?
Yeah.
Okay. So why don't we, you know what? We're just going to move right into this.
Yeah.
Right next to it.
Mm-hmm. I love how down to the wire this is. We have like 7 minutes left. You successfully wrote a temporal workflow just basically on the spot here.
How dare you?
We're getting...
What are you even mad about, bro? Cannot find module worker TS. It's right here. Look, there it is. You jerk. Bro. Oral worker.ts. I swear to God, this thing is killing me. Cannot find apps, boxed source lib temporal activities imported from temporal. Do I need it to be like a .ts? Is that the problem?
Not when I do it. So
knows, man.
that's going to be
goofy.
environment specific, and I'm not sure exactly why. Basically, that's just like
require is not defined. Okay. So
yeah, you're getting weird transpiling stuff. It's getting mad at us.
Okay, so I don't know why this is happening. Can I just import this from NodePath?
Yeah, we did everything right. We're just at the part of the exercise where we're like picking and mixing like TypeScript versus like vanilla, and that can be really annoying to do depending on what the environment you're already building in.
Oh, how dare you! This is the worst. No such file or directory.
It's just that the imports are not working for some reason due to like whatever like
weird
we got transpiling we're doing.
Something goofy going on here.
Yeah.
Type stripping is an impairment. Okay, fine. Create worker.
The funniest part is we're probably at a point where you could ship this and it would actually work because whatever is breaking based on like a weird local TypeScript environment thing.
I know.
That is not my
and we
forte.
just don't have time to ship it, unfortunately.
But
I really want to see this work. Come on, bro.
We basically did it. And this you know what? Like this is actually like I'm very happy with the work we got done here. And like transpiling weirdness aside, like you basically have a working temporal app here that you can now take from here. So
yeah. Okay, so no such file or directory. Is it because it's probably because of this .ts thing again? So let's try this one more time.
Like goofy transpiling stuff at this point.
Please just work so that we can see this goddamn thing function. No such file or directory. Foxhud workflows.ts. Okay, so it's resolving from the wrong place. So we're going to source lib temporal. And now that path should work based on where it's trying to resolve from. And aha! Okay.
Okay.
Okay. 2 minutes. Here we go.
So go ahead. You can refresh this, and now we got a running workflow. It successfully ran your first activity. See that? So it's
okay. So there's our thing.
Our first activity ran. You see some input persisted back to the service. Yes.
There's the result. And no, we didn't log that. That got picked up by
exactly. That's automatically persisted back to the temporal service. We have a running workflow.
So now if I go here,
hit the other route, which should send that signal.
So I validate that does the thing, and then I come back here and we have code is valid. Give them a PS5.
It received the signal and it ran the second activity, and our workflow is complete. There you go. Beautiful.
Woo! Literally down to the wire. Thrilled that worked.
Yeah, I am really pumped that we got that done exactly in time.
Okay, so
you thought I was talking too much.
just to recap, what we ended up getting done here is we got basically a human in the loop durable workflow, and we can kind of see how that functions. So we set up the workflow. There's a little bit of boilerplate going on with this to make this all run. We set up a worker, which is sort of the thing running in the background. This has to be a long running process. So this is the part that we would deploy to fly.io, to render, to Kubernetes, to whatever. And then the rest of this can all run serverlessly. And so we've got our activities doing the work. So loading my things, running the logic to validate my my stuff. And then this workflow is just calling those things and orchestrating how they work. So, you know, loading the stuff, then making sure that we wait for the person to say, do the thing. Once they say do the thing, it completes the next step, and then it returns a value. So from a, like, this is why this is so powerful. Once you get this boilerplate set up, everything else that we're doing is really straightforward. For me to set up a workflow is just saying, okay, I want you to do this, and then I want to wait for somebody to do this, and then I want to do this. And for the activities themselves, this is exactly what I would write in my own utility libraries. Like, there's no magic here. We're not even importing anything from Temporal. So that's why this is cool. And that's why I think, like, I hope everybody stuck through to actually see this result for why it's worth setting up this thing, because then we get this really good visibility into what the heck is going on inside of our functions, right? We can see what went in, we can see what went out. We could see the headers if we had sent any. So when I get into sending the currently logged in user, when I get into sending arguments like task IDs and you know, what event we're at or what prize somebody's supposed to get, I'll be able to go through and actually like peek at each step in the process to make sure that it's doing what it's supposed to do. Holy crap. Alex, this was fun. This was this was a lot. So for folks who want to go further, learn more, where should they go next?
Go to temporal.io, go to docs.temporal.io, go to learn.temporal.io. We show lots of cool use cases, lots of example architectures. We have a new code exchange link from that top bar right there, where you can see how people are using Temporal to build applications in the real world. So you can see lots of sample architectures and lots of fun stuff people are already building. Jason, thank you so much. I am so psyched that we got that, like, Mission Impossible style at the last possible moment.
Really, truly, like the bead of sweat almost killed us both, but we got there.
Yeah.
Thank you all so much for hanging out. Alex, thank you for spending some time with us today. Thank you again to G2I and to Vanessa from Whitecoat Captioning for doing the live captioning today. Make sure you check out the schedule for what's going on. We got a lot of fun stuff coming up. If you're going to be at Render ATL, make sure you come and find me and look for this software in action. It'll be pretty hard to miss if you're on the exhibition floor. That's all we have time for today. Thank you all so much. We will see you next time.